Okay. Hello again. Welcome back. It's not Friday night anymore. It's Tuesday night. I'm still in London. I'm going to do another one of these programming live streams. See how it goes. If you didn't watch the last one, then previously on this stream, I am trying to write a WebAssembly interpreter in Ruby. I'm doing this mainly to have fun, also to demystify WebAssembly for myself and possibly optionally for you if it's something you're interested in, and also share how I do it. What I mean by that really is that I'm trying to get as far as I can just using executable specifications. So just using the tests that come with the reference implementation. So, we'll see how far I can get with that. I've got a few ways that I wanted to go about it. I talked about this last time. It's more important that it's fun than I end up with something that works. It's more important that the thing that I'm writing is correct as far as it goes than that it's got good performance. I'm trying to focus on making the code as clear as possible, even at the expense of it being clever or well designed or whatever. And I'm trying to do it in pure Ruby and ideally not depend on any other libraries, but we'll see how realistic that is. Before I kick off, I thought I'd do just a very quick sort of retrospective, I suppose, by which I mean just have a think about how well it went last time or not, and talk about a couple of things that I've tried to improve this time before I really get into it. Yeah, thanks, James. Yeah, I'm not sure that Tom is greater than Tom minus one. I suppose. Yeah, it must be the case. Welcome, Chris. I hope that you can vicariously learn something about WASM too. Let's see. I mean, I didn't really do very much WebAssembly last time, so we'll have to see. So I'll keep this retro very brief, but I just wanted a chance to reflect on what happened last time. So the first bit of feedback that I got last time, initially, this was from Leo, but also supported by Paul, so thank you to both of you for giving me this feedback, was that the audio was too quiet. So I've turned up the gain on my microphone. It's an analog knob, so it's very hard to know what that should be set to. Let me know if it's now too loud and I'll rotate the knob in the opposite direction, but I'm sort of trying to find a balance between being audible and it being the audio being noisy. So see how we go with that. So yeah, I've tried to fix that. I'm sorry if it hasn't been fixed. The other thing I noticed, scrubbing back through the video from last time, is that it's very strange that when I look to the left to look at a window on the left, I was actually kind of turning to the right because of how space works. So for this one, I flipped the webcam view. So hopefully now when I'm looking at a window on the left-hand side of the screen, I will appear to be looking to the left, which will hopefully be a little bit less discombobulating. So we'll see how that goes. Also, last time I couldn't see the live chat for some sort of boring technical reasons, which somewhat undermined the purpose of doing this as a live stream, because I really don't need the stress of doing this as a live stream if I'm not going to be able to actually if people aren't going to be able to show up and talk to me and ask questions and make fun of me and stuff. So rather than pre-record it, I'm going to continue to live stream it, but I've made it so that I can actually see the live chat now. So if you're watching on YouTube, please do say hello. It will make me feel slightly more normal if I think that there's at least one person on the other side of this rather than me just sitting in my room on my own talking to myself. Yeah, so hopefully that's working. I'm conscious that last time I didn't, although I was trying to think out loud, again, when I scrubbed back through it, I felt like I didn't do a very good job of... I pulled quite a lot of things out of thin air. Like when I was talking about regular expression syntax, I just, because I sort of remember what the regular expression syntax I needed to use was, I just typed it in and carried on. And I think maybe it'd be better if I remembered to show my working a bit more. And what that means really is just pull up documentation. If there's something I want to use, sort of find where I'm getting that from, because I think that's potentially more useful to anyone who's watching who isn't familiar with that thing, just to kind of show where it's from, rather than just magicking stuff out of my own brain. So I'm really just putting this here to remind me to do it. It's I know it's boring to hear it, so I'll move past that. The other thing is that last time I sort of forgot to take notes, and as a result, I said I was going to do things and then I forgot to do them. Like during last session, I said, oh, the private keyword is in the wrong place and I want to move that somewhere else. But then I just sort of immediately forgot that I wanted to do that. So I'm going to try and make myself take notes this time. I've got this sort of notes, Apple Notes window that I'm going to try and type notes into so that I don't forget what it is that I'm trying to do. And I can put some to-dos in there as well. So I've already put a few to-dos in there. I can put a few more in as I'm working, and then hopefully that'll be a little bit more reliable. What else? Oh yeah, I didn't actually share the code I wrote last time, which was a bit of an oversight. So I'm gonna make a repo on GitHub and push it up there so that it's unlikely that anyone else wants to run this code right now. But I think it's nice to sort of, as I'm working on this implementation, I sort of want to put the code somewhere where other people can, I don't know, clone it and run it, or at some point, if it actually becomes capable of doing something useful, it would be nice to have it out in the world. And I think it's probably better to sort of share early and often than to somehow jealously hoard this terrible code that I'm writing. So I'm going to try and put that online as probably as part of this session. And the final thing was I just wanted to remind myself that I'm trying to build a prototype here. I think I constantly feel this sort of temptation to try and start thinking about object-oriented design or test-driven development or whatever. And like I'm really interested in all that stuff, but I'm just trying to stay focused on the idea of like the main thing I'm trying to do here is to learn enough about WebAssembly to be able to execute some subset of it. And I just need to restrain myself and not allow it to become an exercise in, architecting an interpreter or whatever, because I think that's sort of not necessarily less interesting, but that's not what I want to get out of it. I want to try and grind through the actual details of WebAssembly and get somewhere useful. So again, I'm just reminding myself this is supposed to be a prototype. That's it. End of retro. That was easy. So hopefully now we can forget all about that and I can get on with actually trying to do something useful. Like I said, I kind of write myself some to-dos here. I said I want to move private to the right place. I hope this text is legible. Do any other refactoring before continuing? Yeah, I feel like maybe at the end of last time I could have spent 5 minutes like cleaning up that code a little bit, but instead I was just like, well, it works, goodbye. So I'm going to do a little bit of that. I'll push the code up to GitHub. I put here run test with GitHub Actions. I don't think I am going to do that today. That's just a reminder of something that once I've got it on GitHub, it'd be nice to just put in a workflow so that those tests I wrote actually run when I push the code, just because that's a nice thing to have. And yeah, I put final refactor and clean up before stopping. Yeah, that's reminding me to not just, when I get to the end of this stream, I want to take a second to like do a bit of refactoring before I just kind of ship it, because then I'll forget what cleanup I wanted to do and stuff. Okay, so where did we get to? Yes, okay, add support for escaped quotes inside string literals. Right, so previously on this, I was able to, what was it called? WASM spec, test core tokens.wast. Yes, I was able to successfully parse this file, which is just S expressions, but with a specific syntax of what constitutes an allowable atom in the S expression. And I think I managed to convince myself that this was all working correctly. And more particularly that it was able to parse that, was it int literals.wast Yeah, because this is the thing I'd really like to execute. So I think this is what I want to look at today, is actually trying to evaluate this thing, implement some of these assertions, get into the details of, whatever is being exercised by this code, which to me looks like it's mainly just about conversions between hex and decimal, but like it's a good path into actually being able to evaluate this. I am just going to clear my plate of a couple of these things before I get started, though. So I'm going to do that. It says move private to the right place. If I'd done this last time, I would have done an interactive rebase to sort this problem out. But given that it's been a while since I actually did this, I think I'll just make a new commit with this in. So what I really want, and this wasn't intentional, but what I really want is for just this parse method to be part of the public API of sExpression parser, that I did not deliberately put parse expressions and parse expression in the public API of this thing. I wasn't paying attention when I was writing those methods last time. So I've moved that up. Also, for whatever reason, I prefer to have these attribute accessors like here, like after the private line. I don't have a good justification for that. It's just the way I like it. I like to have public API and then the private keyword, and then here I just declare whatever getters and setters I'm going to have, and then actually implement all of these methods. So that's the way I would like that to be. So that looks okay. Move private and attribute accessor further up the file. So that's not a big deal, but that's just something that was sort of slightly nagging at me from before. So I've not now, macOS. Do any other refactoring, e.g. extract helpers before continuing? Yeah, okay. So this was, I think I sort of mentioned this before, but I didn't actually do anything about it. That so there are two things. One of them is that there's a bit of repetition in this code here that, while I don't want to disappear down a rabbit hole of, doing anything clever, this code is basically repeated in these two places. So I think it would be a good idea to have a method that, really it'd be nice to call it match, but that's a little bit, that's annoying for two reasons. Firstly, the method we're calling it on the regular expression is called match, and that's not inherently a problem, but also this local variable here is called match. So I don't know what I'm even trying to do there. Oh, I'm trying to just highlight that word. My fingers weren't on the right keys. What I want to do is sort of pull this out. I'll call it try match, just so it's got a different name. What I want is to pull out this so that I can try match here. And then reuse that here. So this is a predicate. So what I want to know is whether this is not nil. So has this, the way this match method indicates success. So this is an opportunity. Match. Or nil if there was no match. So yeah, because that communicates success or failure by returning nil or not nil, I want to know, is this not nil? So that way, this kind of munging of regular expressions gets kind of localized. And let's check that that's, how's that looking? Okay, yeah, that's working fine. All right, so I'll, let's say extract try match helper, and I'll just write this helps to avoid duplicating the slightly messy construction of a regular expression that matches at the start of the current string. That is why I'm doing that. The other thing that slightly bothered me was just this long line here. And the fact that I had to use, it's slightly unusual for me at least to use this or, the actual word or. So that made me think that I could extract this into some kind of complain helper. I guess that needs to be parameterized on the pattern. And then that would let me do this. Again, I think that's slightly nicer. It makes that line a bit shorter. I think this is a little bit easier to read. It was slightly bothering me that that line was a bit long, and the fact that I was having to worry about operator precedence here. So now having extracted this, I think it will be fine. Yeah, I mean, it's, I'm not actually raising that exception at the moment, but I feel pretty comfortable that that's okay. So extract complain helper, and then I'm just going to say this avoids having to use the or keyword, which is slightly unusual, and means I don't have to worry about operator precedence. It also avoids a long line. Okay, so that's done. The final thing that kind of bothered me while I was doing this, working on this last time, that I didn't do anything about, was the sort of asymmetry in this parse expression method. Again, I don't want to dwell on this, but the job of this method is to pick between doing three different things. It's either going to read a list, or it's going to read a string, or it's going to read an atom. And there's no meaningful reason that this doesn't live in its own method. So I'm going to put this in its own method. So this is going to be, parse list, I guess. And then let's do it here. Oops. So again, that's not an interesting change, but yeah, that looks good. I just think that makes it, it means that this is sort of, these abstractions are sort of on the same level, rather than having one of these be arbitrary in lines, which was just, that's just where we got to organically writing the code last time. But I think it's sort of nicer to break it out like that. So I'll say extract parse list helper. What do I want to say about that? Well, I guess what I was saying was this just makes parse expression a bit easier to read. That's really all I care about there. Yeah. Okay. Done. All right. I think extracting helpers was the only thing that I was particularly interested in refactoring there. Okay, push up to GitHub. Okay, let's do that. So I want to make a repo in that GitHub repo. So yeah, I did think of a name for this. Instead of this being WASM, I'm gonna call it WASMinner, and call this repo WASMinner. Ruby implementation of a WebAssembly interpreter. Create repo. All right. Git remote add origin. Rename wasm.rb. So wasminner.rb. I'll put some justification here. Okay. All right, so there we go. We're cooking on GitHub. That's all I wanted to do really, is just remind myself to push it up to GitHub and make it available there. Maybe I should add a license while I'm here, just because otherwise someone's going to complain to me about this. Let's go with MIT. I do love free software and everything, but I think being more permissive is probably good. Okay, how do I commit this to main? Okay, add MIT license. Now, I'm British, so I spell it that way, but GitHub doesn't. Has that all worked? Yep. Okay, that looks fine. All right, well, that's that chore over with. Okay, I've done that. I'm not going to do run tests with GitHub Actions, and I'm not going to worry about doing any more refactoring. Okay, all right, that's the annoying busy work out of the way. Let's get stuck into, well, I suppose what I will do is have a look at that. Have a look at that file that I was hoping to be able to interpret. So it was intliterals.west. Okay, so in fact, let's have a look at the, I'm trying to remember what the syntax, I feel like what I want to do is use the right nouns to refer to these lines that appear inside a module, and I'm not quite sure what noun to use, but I think in the reference interpreter, because they talk about the syntax of the test script. Oh, commands. Okay, yeah. So commands are like module. Okay, so module is a command. So this. Okay, all right. So this is one big command here as far as the test script is concerned, and what this command does is declares a module with a load of function exports in, and then all of the other commands in this file are assertions, I think. Yeah, and these, again, I think I'm probably going to ignore these assert malformed for now. What I'm interested in are these assert return assertions, because these seem to be checking, in this case, that hex bad dude is the same as decimal 1955940 0365. So let's, what do I want to do? I think essentially what I want to do is read in this file and iterate over all of the commands and execute them, right? I was just getting a bit distracted then, because I was thinking about what I want to do about what happens when I actually run this file. WASM spec test core int literals. I'm thinking about whether I can keep all of this in the same file still, or if I need to break things out. I think it's okay. It's just that these, really the thing that I'm actually worried about is that these tests are going to become a bit of a distraction. Why don't I move these out? Oh yeah, and indeed this this sort of executable bit here. I'll at least, those sort of, as that's unit tests there, I'll put in sexpression parser test.rb for now. How do I want this to work? I mean, I might as well go whole hog here. I might as well move the parser out. Like, you know, I was thinking what I want to start doing is having like class interpreter here. But if I'm going to do that, if I want the tests to be able to still work, then I might as well put this somewhere where they can load it without also kicking off what I've got in this main here. So, I mean, maybe I should have done this, you know, right at the beginning. But I was being sort of unnecessarily minimalist about everything. So let's just... So that lives in its own file now. This... what do I want to do here? I think what I want to do is just use require, and then I don't mind being responsible for... I would rather take responsibility for managing the load path than use require relative here, and then if I decide to move things around into subdirectories or whatever, I'll have a load of busy work to do. So I think I'd rather just make it so that when I run this... So clearly, right now, this is going to need S-expression parser to work. So all I've done here is, I guess I've decoupled those little tests from my main executable. So I should be able to do wasm.rb spec wasm spec test core in literals. Okay, so that still works, but I should also be able to do S-expression parser test. Okay. Yeah, I mean, I assume that. Yeah, that's obviously done something. Well, maybe not obviously, but I believe that that's done something. Okay, so that's all dealt with, basically. I'll make a commit there, because that feels like... So I'll say split out S-expression parser and tests into separate files. Why am I doing that? I'd like to start building an interpreter in wasm.rb, so it's going to be easier to do that if I don't have all the parser stuff getting in the way. I've used require rather than require relative because I'd rather shoulder the burden of setting the load path myself than need to go and fix up paths later on if I decide to move the files around. I may live to regret that decision, but I feel like require relative is... feels like it's going to be easier, and then actually it just ends up causing a bunch of hassle, basically. So, all right. So, in that case, like I said, there's going to be... I'm going to want some kind of... I mean, maybe this isn't the right name for it, but it's going to execute the thing. It's going to interpret this test file. So let's call it interpreter for now. So now I guess what this main is going to do is... I was just thinking, should I get rid of this? But I've decided not... I've just decided silently to not get rid of this because I'm probably going to end up putting some more, raise and less something stuff here. And so I want to retain the ability to run this file with no arguments if I just want to run those little tests. So this is fine. I want to parse the input and get an S expression, but then I want to do something like interpreter.new. I don't know, interpret, evaluate. Something like that. Yeah, I'm just thinking about like, I'm thinking about the fact that what this is going to do is, this is only going to be about evaluating that sort of top level script. So I'm thinking about naming, but maybe it's not important. Let's call it interpret. I'll probably want to revisit these names later. I don't think I sort of, there's not an interesting result that I want to print there. You know, the reason why this is interesting is because this is going to run some assertions, right? So I don't really care what the result of this is. It's just the side effect of running this is that those assertions are going to pass or fail, essentially. So I think that's it, probably. So I know I should just be and I've typed this a bunch of times. Int literals.wast. Okay, yeah. Don't have an interpret method yet. So I'm going to switch to using, I think what I'm interpreting here is a script. Again, looking back at this, yeah. So I'm going to try and stick to the nouns from the spec here, just to sort of keep my head straight. So now hopefully this will work. Yeah, there we go. Okay, well, I'm going to commit that because that feels like I've done something. Add skeleton of interpreter class. I've just realized that I should, I'm setting myself up for trouble here. There we go. Fine. Okay. So, all right. Well, let's get interpreting. So I want to iterate over all of these. Scripts.each do, these are commands. And then a command can be a module or an action or an assertion or meta. So at least initially, I mean, let's just build this up incrementally. So let's say case command. I mean, if this is a fantastic opportunity to use pattern matching, so I'm just going to take it. So if the command is, if it starts with module, and then what's this going to be? What is inside a module? I mean, maybe I shouldn't be. Maybe I don't need to look at this spec quite so much, but I'm more fishing for nouns than actually. Okay, like, I mean, this. Okay, so module syntax is a little bit messy, but it certainly starts with the symbol module, and then it looks like there's an optional name, 0 or more type defs, 0 or more function definitions, imports, exports, tables, whatever they are, memory, whatever that is, globals, whatever they are. Okay, so there's a load of stuff. I'm not quite sure what this is, that you can have a type def and then another module. Anyway, yeah, obviously I don't understand enough about the, oh, these are alternatives. Okay, yeah, I didn't realize that their BNF here, like, doesn't have any kind of pipe in it, but okay. Anyway, all right, so module is just the module keyword and then a bunch of junk afterwards. So if it's a module, then, well, let's just print module. See how far that gets. I've misunderstood how patterns work, haven't I? what do I need to do? I think I need to put a keyword in here. Is that right? Something like that. I've just realized it's because yeah, that is a bit awkward. Okay, does that work? Yes. Okay. So despite me saying pattern matching, I didn't actually make a pattern there, did I? Well spotted, nobody, including me. Okay. All right. Cool. And yeah, so it does print out a module, and then it's saying no matching pattern error. So if instead of module we get whatever it is, assert return, so okay, so you know, we're sort of chewing through what is written there, and assert malformed. Okay. Okay. Okay, great. So in some sense, there we go. We've interpreted it. It's not very good. This one is just going to be a, you know, I'm going to do that later. These are the two that I want to deal with today. So just going to think briefly about how this works. One reason I'm thinking about this is because I sort of assumed that there would have to be some kind of explicit connection between, like, there's a module being defined here, and then we're saying we want to invoke this function, but how do we know that we're invoking the function in this module? And again, I'm saying this as someone who doesn't really know anything about the semantics of WebAssembly, but like, just as a lay person, it seems like you need some kind of, if you're going to have modules, then you might have more than one, and then how do you know which module to find this function in? So that's, my brain is just snagging on that slightly. So I'm just looking at this documentation to see what it says about this. Commands taking an optional module name refer to the most recently defined module if no name is given. Okay, so I mean, it's not so much the assert here as the invoke that is, yeah, okay. So invoke does, well, it takes an optional name, and I assume that the name there is the module name, like here. So this is defining an anonymous module, and then these are sort of implicitly invoking functions in that module because it's the most recent one that was defined. So for now, I think that means we can probably get away with just sort of, for the, you know, I'm going to trying to stay focused, right? We don't really need support for multiple modules to evaluate this file because there's only one module in it, and all of these invocations are referring to functions inside this module. So I think, you know, as long as we don't touch these assert malformed. So I think for the purpose of just implementing assert return, I think all I need to do is iterate through the contents of this module. And what does it call? Func. It doesn't really have a generic name for. There's clearly all kinds of things that you can put inside a module. So it's like iterating through whatever is inside this. Every time we hit one of these func lines, I'm going to need to remember, well, the name of the function that is being defined, which for all of these just appears literally inside export here. So you can, well, I will, instead of just talking, I will show you what I mean. So I think inside here, you know, these are like, I don't know what to call them. I'll just call them expressions for now. Because I don't think this grammar really gives me anything to hold on to. So let's just say you've got a load of expressions, and then I'm going to say expressions each do expression, and then there's going to be a case expression inside here, and then I'm going to say in, not when, func. Like what I'm going to write here is just going to be, I'm sure that there, just by looking at this grammar, I can see that there's all sorts of optional bits and pieces. So the eventual pattern here needs to be way more general and way more flexible than this. But for right now, and just for the purpose of getting this working, I can look for func export name. So this local variable will match whatever the second element of that S expression is. It says result I32. I'll just put that in so that sort of as a placeholder. I assume this is the result type, I32 being, I think, a 32-bit integer. So this is sort of declaring the result type of this function, probably, given that what happens is we invoke this and we get assert return is checking that the result of invoking this function is the same as this 32-bit integer constant. And then there's one more thing in the array, which is the body. So let's check that. Function called name with body. Body. I suppose I should. This is going to be one of these quoted strings. So, well, I'll inspect it just to make that point. What have I done now? Once again, I've wholesale forgotten how Ruby's syntax works. Blame it on the pressure of live coding. Okay, so yes. This is, I'm going to say named, not called, because as soon as I saw that, I was like, how's the function been called? It hasn't been called, it's just named a thing. Okay, function named blah with body blah. Okay, right. So we're finding all of these functions. I will stick them somewhere. Like effectively, what I'm thinking is I just need to remember the names and the bodies of all of these functions. So I could just as well stick these in a hash or in an array or whatever. I guess I don't know anything at all about the semantics here. So like, for example, is there any reason I shouldn't just put them in a hash? Probably not. I feel like I could probably get away with that. So, okay, this is also gonna be a to-do. What I'm doing here is acknowledging that I'm focusing on implementing this like module definition now. So let's say that we have an empty hash to begin with. This is obviously not going to stand up for long, but I think it will allow us to interpret this file. So we start with an empty hash, and then when we hit any module, and then when we find any function definition in it of this exact syntactic form, we're going to add the function to the hash. See, now the reason I'm hesitating is because I think what I want to do here is have some kind of representation of functions where I can say like, make a function that's got this name and this body. But now if I stick that in a hash that's keyed by that name, then I'll kind of have the name in two places. I think what I'm going to do is make this an array instead and just push it onto the array. So I'm kind of accumulating these function definitions as I go. Maybe this class should be called function definition. But that's what I want to do for now. I'm slightly anxious that this function name is like, it's like this uninterpreted string literal. The backslashes are only there because I called Ruby inspect on it, but the name of this function at the moment is literally open quote and then the body of the string and then close quote. Whereas what I would really like to do is sort of evaluate that to get a string. So that would remove the quotes. It would unescape any quote characters, any escaped quote characters that were inside the string. But I think I'm just going to ignore that problem for now. It's something to deal with later. This is the kind of thing I should be making notes about. Function names are currently raw symbols from the yes expression, i.e. they have enclosing or surrounding and potentially contain escaped quotes. At some point I should convert these to string values, i.e. strip the surrounding quotes and interpret any escapes inside the string. Okay, I mean, in some ways that's a to-do, but I wanted to explain because I'll forget that. Yes, okay, so I'm going to punt on that for now and make that sort of future me problem. Sort of tempted to run this, but I don't think anything's going to happen if I do. Well, one reason why nothing's going to happen is that this function class doesn't exist. Let me define that. Name, body. What's the thing that lets you provide keyword arguments to struct? This is a good opportunity for me to look at the documentations now. Oh, well, in fact, why don't I feel like it would be a little bit more visually appealing if I looked at this documentation. Docs.rubylang.org, English, Ruby 3.1. Where's struct? It'll be here somewhere. I do know about searching, by the way, but I've sunk a full 10 seconds into scrolling this, so I feel like I need to make good on that investment. Keyword init. For some reason, I can just never remember this. And what I'm talking about, if you're not familiar with this, is that the constructor of the struct class has got this keyword init argument, which lets you specify whether it's okay to pass the arguments of the struct in as keyword arguments. And I think maybe is this going to be the default in Ruby 3.2? Maybe. I can't remember. I've got a vague memory of something like that. But for now, because I am on Ruby 3.1.2, I have to say keyword init. I guess true. That's probably what I want. Okay, so that's what I want to write. I mean, nothing bad's happened. It feels like it's been a long time since I made a commit. And yeah, I realized I haven't I haven't really been writing any little unit tests. I've just been plowing on with trying to implement this according to what's in this file. I'll see how far I can get. Like, I'm not going to write tests just for the sake of it. Like, this, I'm sort of comfortable with how I'm doing this so far, so I'm just going to carry on. So what have I done? I think what I'm going to do is just do a sort of stripped down version of this. I'm just going to say, basically, like this kind of do nothing version of interpret. Because I think that's, so this is sort of like add skeleton of interpreter.interpret. We need to iterate through all of the in the script, which so far, i.e. for int literals.wast, are only module assert return or assert malformed commands. Yep. Okay, and then I mean, I'm not exactly done, am I? Well, maybe I sort of am for module. Like, yeah, maybe that is okay. So this is like remember store function definitions when interpreting module. So that's probably enough to be getting on with. So now I need to think about how assert return works. How does this work? Assert return invoke blah. Okay, so I think again I think I'm gonna be lazy and make this, only support, because here it says assert return takes a sort of a general action here, but I'm just gonna make it only work if the action is invoke. So invoking some function by name, and then here there's a sort of, this is the expected result of invoking that function. I mean, just looking ahead, is it dangerous to look ahead? It might be. Yeah, I won't look ahead. I will just, I think what I'm going to do for right now, we've got these i64s down here. I was going to say, like, just hard code this to work with i32.const. And just yank this value out in the pattern match, basically. I think I am going to do that for right now, and then we'll cross this 64-bit bridge when we come to it, which, depending on how difficult this is to get working, might not even be in this session. So, yeah, let's see how far we can get with that. So this is going to say i32.const value, or shall I call this like expected value? Yeah, okay. So just sort of explaining my assumptions here, I'm assuming that this instruction is for, well, because I know that WebAssembly is a stack-based virtual machine, I assume that what this i32.const does is pushes a 32-bit integer onto the stack of the virtual machine. I'm not, at the moment, I'm not making any effort at all to implement any recognizable virtual machine. I mean, I guess I'm keeping a list of function definitions that I've seen. So I'm not going to meaningfully push. I mean, I'm not even really trying to evaluate this expression here. I'm just pulling out the expected value from it for as long as I can get away with that. So I'm not going to try to push it anywhere. I'm just pulling it out directly for the moment. Maybe at some point I might end up having to like properly evaluate, because this is an arbitrary expression, right? Assert return, yeah, result. Although actually it says it can be a const, which is one of these things. So there actually is maybe this is appropriate. There is actually a very narrow subset of expressions that can appear here, or at least this const thing. I'm not sure why this needs to be one of the alternatives for result, given that, this is numpat. What's that? Oh, okay, all right. That's a distraction, but that's noted for later. That the result here that we're comparing it against could be, I think all of these are probably just like legit WASM instructions, whereas I can see that there's like a special thing here for being able to match. I won't get into this now, but I can anticipate that what's going on here is that this is to support writing assertions that say I should receive some kind of not a number value. I should receive some canonical not a number value, or I should receive this specific not a number value. We're not worrying about this yet because we're not implementing. Not a number is a kind of float, and we're not doing that yet. So I'll make a note of assert return has an extended syntax for its expected value, which allows it to match nan particular kinds of nan value. So we can't just evaluate the expected value as a normal WASM expression, even if we want to, because it isn't necessarily one. So that kind of vindicates the approach I'm taking here, I think. Like, because there's a limited number of shapes that this expression can take, I might as well just do something like this. So that's a very long-winded way of saying Tom was right. The thing I did for a bad reason is actually correct for a good reason. All right, so we've pulled out the expected value. We've got the name of the function to be invoked, and now all we need to do is simply check that invoking that function returns the desired result, which is, of course, the tricky bit. So really what I want to be able to do is say actual value equals, something. And then I suppose which way around did I do this in the... I feel like test unit and mini test have sort of poisoned my mind about what way around comparisons should be. Yeah, look, they have actual equals expected. Oh no, they haven't. They haven't poisoned my mind. That's what's going on. Okay. This was a bit of... Okay. So if actual value equals expected value, then like success, else, failure. I'm not quite sure what success and failure are going to look like. I mean, success might just be do nothing. Although maybe it would be encouraging emotionally to do something on success. Like, it feels a little bit sad that, you know, when I was doing this, it's like, if everything works, then nothing happens. Like, that feels like a pretty paltry reward. So so maybe I could print something out that says, like, you know, that this test has succeeded, but whatever. The failure, what do I want to do? What I mean by that is, do I want to accumulate failures and like print them all out at the end, or do I just want to raise an exception? I think I probably just want to raise an exception at this point. Raise expected value. Got actual value. So maybe here I'll just do something like you know, I'll just print out that they're, so that when I run this, I get some kind of, like I say, sort of encouragement. I thought this, I was confused by the fact that I hadn't, that the syntax highlighting was all wonky. I was like, oh, it's because I've forgotten a quote at the end there. Okay, so really the only challenge here is computing this actual value, right? Somewhat unsurprisingly in this interpreter, the only difficult bit is the interpreting. Yeah, good point, Chris. I think it would be a little bit risky to not print anything here, because then I would, as you say, I wouldn't even know that this that the code was doing anything, that I'd even, you know, it might be that that control flow never hits this section of code. So yeah, I think that's a good point. It would be taking a bit of a risk here to not at least show that I was evaluating the assertion. So I'm going to have to actually, I feel like I've been dancing around this for the last hour, but I'm going to have to actually do some work here, aren't I, to evaluate this. So let's say, well, firstly, fortunately, there's no arguments. This is only invoking sort of nullary functions, at least as far as this test goes. Oh, the functions themselves don't have arguments. I was just remembering that there are some of the bodies here are actually, you know, not entirely straightforward, but I reckon, well, okay, now let's, I keep, you know, wanting to type something there, but I'm not really ready to. Let's say function equals functions dot, I think it's detect that I want. Returns the first element for which the block returns a truthy value. Yeah. Oh, it's also called find, but for some reason I've decided I want to use detect. I think it's because, I think the reason I don't like writing find here is because of Rails. I think this makes me think that this is some kind of active record association. I know that doesn't make any sense. I don't know where that thought bubbled up from my mind, but apparently that's how I feel. So so I want to detect the function whose name is equal to the name that we had here. So this is effectively looking up the function. again, I'm going to be a bit defensive and say raise couldn't find function name if function is nil. So again, I think if we look at this, it will say if no such element is found, calls if none proc and returns its return value. If none proc, what even is that? I don't even know what if none proc is. Like this this documentation isn't very good because it doesn't tell you what that is. As you can see, I have now discovered the innovation of search. Oh, I mean, this documentation, this web documentation doesn't even mention that. Oh no, sorry, it does. If none proc. Oh right, you can pass in. Yeah, this documentation needs to be improved so that it makes sense. But it's because it was an alias, so maybe it's a problem with RDoc or whatever is. I don't know what generator is used to generate this documentation, but yeah, okay. Oh, sorry, this is a huge distraction. We don't care. It's by default it returns nil. That's the point. So we're gonna complain if we can't find the function. Okay, so now we've got the function body, which is going to be something like return i32.const blah. Just thinking ahead to how I want to deal with this. I mean, I could do the same thing again, right? I could just match this value out. But I'm a little bit less comfortable with that because now I know that we're definitely into the realm of like arbitrary WebAssembly instructions, right? Like this is real WebAssembly code that is returning a value. What do I want to do? I think I don't have a very good justification for this, but like my gut feeling is that this is the point at which I would like to start just treating this as an arbitrary expression that we're going to evaluate. So for that reason, i.e. no reason apart from just it's because of how I want to do it, I'm going to I think this is going to be the point where I say actual value equals evaluate function body. And I'm very aware of the fact that this evaluate function does not yet exist. But this feels like the thing that we want to do is like look up the function that we're invoking, evaluate the body of that function, and then check that what we got back was correct. So I'm hoping that's all syntactically valid Ruby, which is increasingly not a given in this code I'm writing. Oh yeah, okay, it is. Undefined method evaluate. Okay, cool. So I'm starting to get a little bit nervous that I've written quite a lot of code and I haven't made a commit. So I'm just thinking about like, is there some kind of meaningful... Yeah, I guess there is. Because yeah, I mean, I'm just going to commit like less of this. I'm just going to commit this bit. Because at the very least, that is looking up the function that's being invoked. Look up the function being invoked by assert return. Like, that's a thing. I can't really... None of this code is meaningful until we've evaluated until we've evaluated the function body. So am I still, where am I? Yes, okay. So expression. So I think this is, I sort of wanted to get to this point. I wanted to get to the point where we're sort of dealing with, I think this is why I was hesitating. Oh yeah, let's make this private. I was sort of hesitating earlier in the naming of this because I was sort of conscious that this top level loop where we're iterating over all the commands is not really the same as evaluating a WebAssembly expression. So I think I was anticipating this split, and that's why I didn't want to call this, I mean, interpret and evaluate are not very good, not very distinguished names. So I need to think about this. Maybe this should be called interpret script or something, or execute script. But anyway, I think that is sort of acceptable. Right. So let's make these inspected, because if it's a failure, then it might be useful to see that we expected this thing, but we got nil. Oh yeah, this is a string. Okay, that's another thing to think about. The expected value in assert return is a string, but i.e. a raw symbol from the S expression, but we need it to be an interpreted value. So I think what we're driving towards here is that we're going to need some function that knows how to interpret integers syntactically, and we're going to need to call that on this and on this, right? So no big deal, but just, it wasn't until I put the inspect in here that I was like, oh yeah, it's actually a string. So I'm glad I did that. And in fact, maybe I'll put that here as well. Expected value. Yeah. Okay. Yeah, it makes me, sorry, I'm getting a bit distracted here, but it makes me realize that like it's not expected value, or at least it's not this. It's not what appears in the pattern that we actually want to do the comparison against, that like this actually has to be interpreted as this expected value needs to be interpreted as an integer, but I'm distracting myself. The point is that I think you could almost reasonably commit this, say, add skeleton evaluate function and hook it up to interpret. So this doesn't actually return anything useful yet, but at least it's being called at the right place. So maybe it would be useful to, well, let's just play on with this, implementing this evaluate. So for now, we're expecting this to get return i32 const. Okay, so I'm a little bit, also looking ahead to this, my brain's tripping up again because I'm slightly confused by how this is supposed to work, because we looked at this before. This example program that I evaluated using the reference interpreter, you can see here that it calls, like, this is what I was expecting to see something a bit more like this, right? Where you get this sequence of instructions that says like, do this thing, then do this thing, So like push these two values onto the stack and then call add with no arguments, and that's going to consume the two values on the top of the stack. And this code doesn't look like that. It's like inline add, and then here are two arguments. So I don't think that massively matters. It's just slightly surprising. It looks like arguments to something like i32.add can either be values already on the stack or inline arguments. Is this really true? It's more of a curiosity than anything, but that's something that I want to be aware of in future. But anyway, the point is, it looks very much as though I'm going to be able to get all of this working just by sort of recursively evaluating. So if I want to return some expression, then I should just be able to evaluate that expression, and then the value of this whole thing is going to be the value of the return expression. I mean, I don't know what the significance of return is here. This is... Oh no, look. I was going to say this is making it look like when you want a function to return some value, you have to use the return keyword. But then even in this same file, here are functions that presumably i32dexcep, yeah, like these are being called and they need to return values. But these functions don't have return in them. So I don't know whether this is actually semantically significant or if it's not really doing anything. But given that I can see I need to support ones both with and without return, I think what makes sense is for me to implement this as expression. This again, if I can remember how pattern matching syntax works, you know, that I should be able to say, well, if the instruction is return, I'm hesitating over what to call this. Return expression, is that safe? Then it feels like I should just be able to return the, you know, the result of evaluating return expression, you know, like that doesn't really do anything. But now, right, now it's saying it's trying to recursively evaluate i32.const, bad dude, and it's complaining. So this is getting us pretty close to where we're actually going to have to do something interesting. i32.const, I'm hesitating because I don't know if this can be an arbitrary expression. It doesn't look like it can be. It looks like there's sort of a rule. Well, I mean, it's called const. So certainly in all these occurrences, this just takes some kind of value directly. So maybe I'll just go with that. Right, so, you know, I could just return this, and I get, maybe there's a commit here. I mean, I know that the sort of the tests aren't passing or whatever, but like, there's something interesting here, right? Where it's like, I've got as far as sort of faking the invocation of that function. Like, I've got the expected value, I've got the result of like fake evaluating that function, and at the moment they're two unequal strings. So now this is reduced to the problem of like, how do I intercept this value here and this value here and actually run them through some kind of integer interpretation function that turns strings into integers. And then it'll all be fine. It'll all work. So great. So I'm going to commit this. Begin implementing return and i32.const instructions. I don't even know if instruction is the right noun here. I'm not sure what return does, because based on what I see in int literals dot wast. It seems to be optional. At the moment, i32.const is just returning a symbol from the s expression, i.e. a string, which is not right at all. Okay, so nearly there, he says. It's clearly not nearly there. But it feels like I need some kind of interpretation or conversion or whatever you want to call it, function that turns those strings into 32-bit integers. So let's write that. What do I want to call it? I don't really want to call it interpret integer. I could just call it like string to integer. I'm going to call it interpret integer. I might live to regret it. So if here I say interpret integer, then right, it's the same because this is just the identity function. And I also want it to be I'm just thinking about what to name these things, because this is what I actually want is like expected value equals interpret integer something, where this is the something. Maybe I'll just call that expected. Is that dangerous? Oh, who cares? It's fine for now, isn't it? Like, I think that it's still, failed successfully. So that's at least wired in that function at the right place, which feels like it's something that I can commit. So I can say introduce dummy interpret integer function and use it where appropriate, where needed. So, I mean, the temptation here is to say like, well, there we go. I'm done. Call 2i. That's fine. But of course it doesn't work. Why is that? Of course. Why doesn't that work? Because, in fact, I'm not 100% sure why that doesn't work. Does this? How does 2i work? Okay, all right. It doesn't understand Ruby. Like, the reason I was hesitating slightly is that Ruby does understand this notation for hex numbers. So actually, if I suppose I've never tried to do this, but if this had magically worked, and I think the reason it doesn't is because the radix defaults to 10. A base is what it calls it. Base defaults to 10, so you need to pass in 16 if you want that to work. So it is possible to make this work, but you have to pay attention to the contents of the string, and I think it's probably just silently ignoring. Oh no, I guess it's got special support for having 0x at the beginning. Okay, so I guess it I guess it does support that syntax, but obviously this syntax is not required to get it to interpret this as hex. So what do I want to do here? I think what I'm going to do is I've got to decide whether this, in order to turn this into an integer, I've got to decide whether it's a base 10 integer or a base 16 integer, right? So, I mean, well, I'm just going down a rabbit hole in my mind of like, do I want to do it with the regular expression, or do I just want to ask if the string starts with 0x, or I suppose it doesn't really matter. It doesn't really matter. Let's just say if string, I can never remember the sense of this method name. Let's mix it up and look on the web. Where's the documentation for string? Oh. Okay, I need to go back a bit. Is it start with? Yes. Okay. So if strings start with 0x, then string.2i base 16, else string 2i, and I'm just going to be explicit about, even though 10 is the default here, I think this makes sense I think this makes sense to be explicit about it, because it makes this conditional, you can understand this conditional without needing the tacit knowledge that the default of 2i is 10. So I think that's clearer. Okay, so just pausing for a second, I must admit I'm expecting this first one to pass now, because I just proved to myself in IRB that Ruby does know how to interpret this hex number, and I mean I didn't actually check it, but it looked the same as this decimal number, so I think this is just gonna work. I'm expecting that first one to work, which means that I am certain that I'm going to get a failure message next, because this is expecting all the F's to be the same as -1, which I'm pretty sure Ruby is not going to agree on. So I'm expecting to see, I should know what the decimal value of this is, but I don't off the top of my head. I expect to see that whatever the decimal interpretation of that hex number is not equal to -1, is what I'm expecting to see now. Great. Expected -1 got very large. I suppose that's the largest 32-bit number, right? All the ones in binary. So I've done something. Interpret, determine the base of integer literals and convert with 2i. Fine. All right, so now we've got a problem, because well, okay, taking a step back, this is making me think a lot of things. The whole point of WebAssembly, or one of the design motivations for WebAssembly, is that it's designed to match closely the immediate capabilities of low-level hardware, right? So is clearly the existence of these I32 and I64 types fits like a hand in a glove to the actual instructions that are available on x86 and ARM processors, right? They have instructions for dealing with 32-bit signed and unsigned integers, 64-bit signed and unsigned integers. But Ruby doesn't. In fact, Ruby works quite hard to sort of abstract all of that away from you. Ruby has sort of arbitrary precision integers, if that's the right. I'm not sure that precision belongs in that sentence, but you can make numbers as big as you like in Ruby. And I don't know of any way to directly tap into, without writing a C extension, I don't know how to tap directly into, oh, I want a value that is a 32-bit number, or like a native 32-bit number. I don't know how to do that. And that's fine. Like, having arbitrary size numbers is great. It just means that I'm going to have to think about this a little bit, because what I'm taking a run up to is the fact that I see that this very next assertion is asserting that -1 is equal to the largest possible, this Umax here to me suggests maximum unsigned. So it's saying that -1 should be equal to whatever that value was, 429496725. So what's going on there? Because it's not the same number, you know, it's a lot easier to swallow that this is just a different way of denoting the same number as this. It's just written in a different base. But here we've got to start thinking about signedness, and it's going to take a little bit of thinking to coerce Ruby into doing the right thing in this situation, because it doesn't intrinsically have this sense that, you know, I can't say to Ruby, give me the representation of -1 as a 32-bit as a 32-bit number. Although as I was saying that, my mind wandered briefly to the pack method, which does let you. This is the only thing that immediately comes to mind that has an awareness of signedness and bit width. But I don't think I want to reach for this just yet. I'm just thinking, could I use this? I might be able to. Because this would let me pack. I mean, I don't really want to use this, but let's just. I need to be able to see this. Why don't I open this in a browser? So this is on the array class. And if you're not familiar with this lets you pack an array of values into a string according to some kind of template. And when I say pack it into a string, I mean a sequence of bytes, really. So this is pretty low level. So this lets you fill a buffer of bytes with some arbitrary values. And really, this is the more I talk, the more I realize I don't really want to use this, but I'm gonna just to complete that thought. If I say -1.pack, and then I say I want to pack that as a 32-bit signed I suppose I don't really care about the endianness, which is whether it's the most significant byte or the least significant byte first, because 32 bits is 4 bytes. Because I'm only gonna unpack it again anyway, so I think this is probably gonna be little endian. We won't be able to tell from -1 anyway. So anyway, so yeah, you see, this is packed into 4 bytes, each of which is an FF byte. So that kind of, that corresponds to what we're seeing here. And then if I unpack that as a 32-bit unsigned value, capital L. Yeah, so which is this, right? So there is I could do this by round tripping these values through pack, right? If I've got a signed value and I want to interpret it as an unsigned value, I could do it by round tripping it through pack. I don't know why I dislike that. It just feels a little bit gross. I was assuming that I was going to have to actually do the conversion myself. I mean, there's a sort of larger question here, which is I've sort of been avoiding thinking about this, but what's actually going on here? Like, why are these values equal? Like, I32, maybe it's time to look at the spec. What's actually going on here? And what I'm thinking about, what I'm hoping I'll be able to see is like some sense of okay, all right. I think this is what I was fishing for, and I do remember seeing this before. So different classes of integers with different value ranges are distinguished by their bit width n and whether they are unsigned or signed. So here, the fact that this is I, the class IN defines uninterpreted integers whose signedness interpretation can vary depending on context. In the abstract syntax, they are represented as unsigned values. Okay, that explains what we're seeing here. So that means that when you write that basically all of these numbers that appear here, or at least that appear next to this I32, because this I class is uninterpreted, it means that we need to store them in a sort of signedness agnostic way, and then when they're used with an instruction that's expecting a signed number, they get interpreted as a signed number, and if they're to be interpreted as unsigned, they're interpreted as unsigned. And I mean, if I'm just waffling on about signedness here, if this is something you're not familiar with, then I'm trying to think whether I can give a really potted summary of it. I mean, essentially, we've got to make some decision about, if I've got an 8-bit, if it's an 8-bit integer, then the most obvious thing that I can do is say those 8-bit numbers represent the integers from 0 up to 255. So if all of the bits of the 8-bit number are 0, then that represents the number 0. If they're all 1s, they represents the number 255, and then everything in between. Or you can say, maybe the easiest way to think about this is if the top bit is 0, then the remaining 7 bits represent some kind of positive number. And then if the top bit is 1, then the remaining bits represent some kind of negative number. So you sort of lose one bit of magnitude and use it as like a sign bit to say whether the number is negative or positive. And then the remaining bits, according to some scheme, denote the magnitude of the number that you're representing, whether it's positive or negative. I mean, obviously the most obvious scheme to use would be to just make it be the conventional representation of that number. So if I wanted to do negative 42, then given that I know that positive 42 is 0, 1, 0, 1, 0, 1, 0, I would just set that sign bit, say, well, this is negative 42. You could do that, but it's actually more convenient to use a different representation where you first flip all of the bits. So now this is called 1's complement. So I've sort of flipped all of the bits in my number to get sort of the bizarro world opposite of the number I started with. And the intention here is that now when you add those two numbers together, that will saturate all of the bits. They'll all become 1, right? Because you've flipped the sense of each of these bits. Every 1 has become a 0, every 0 has become a 1. If you add those two things together, you'll always, in every column, it'll be 1 plus 0 equals 1, and you'll just have a full complement of 1s, so to speak. But then if you add 1 to that, which in this case, if I add 1, that will carry over to there. Now that I've added 1 to it, that means that the sum of these two things is going to be 1 greater than all of the 1s being set. So it's actually going to overflow, like a car odometer ticking over. It's going to overflow, and they're all going to roll over to 0. And long story short, what that means is that this representation of minus 42 is very convenient, because when you add it to the representation of positive 42, you get 0 with like a carry bit that you then discard. So this 2's complement representation, as it's called, is very convenient because you don't have to implement anything specially. If you were going to do something like, there's the top bit is a special sign bit and the rest of the bits just represent the normal magnitude of that number, then in your hardware or in your software or whatever, you'd have to have some special case for like, if the top bit is set, then here's all the logic for dealing with a negative number. Or, if you want to add it to some other number, that's actually a subtraction, because this is a negative number, and then you very quickly becomes quite complicated. Whereas with 2's complement, you just have all of this normal machinery for adding two numbers together, for example, and then sort of in the encoding, you've arranged it such that adding that negative number onto something will effectively do the same as subtracting it, because it's not just if I add this onto positive 42, I'll get 0. It's actually because of that sort of odometer rolling over effect. If I add it onto some larger number or some smaller number than 42, the result will actually be effectively a subtraction, the right result of subtracting 42 from that thing. So maybe that wasn't very clear, but I suppose the point I wanted to make is that even though I just said all of that guff about how there's a way that you can represent negative numbers in binary, it's a question of interpretation, because what I wrote down here, I intended as being the number minus 42, but it's also the valid representation of the number 214, which is, I think, 256 minus 42. Yes, because 256 is the number that's all zeros, but a 1 has overflowed. So it's like 1 larger than the largest expressible number. It's 2 to the power of 8. So, sorry, that was a bit of a digression. I don't know why I talked about that. I think I was just imagining some hypothetical viewer of this who didn't understand what I was saying about signed and unsigned numbers. But the point is that from what I just saw in the spec, it sounds like we're going to have to... Oh, thanks, Adam. I'm glad. I'm glad that wasn't completely pointless then. Cool. Anyway, The point is, what is the point? The point is that we're going to have to, the spec says that we should store all of these numbers as in their unsigned representation. So that makes sense. That makes this test make sense, because what it's saying is, even though this syntactically says -1 and it looks like it's saying the number -1, actually, when we interpret that as one of these, maybe interpret's a bad name because it said these are uninterpreted integers, but when we treat this as an integer, we actually want to think of it as being this number. So the reason why this assertion should pass is because this is just a different way of writing the same uninterpreted integer as this one. So i.e. this, again, 256 minus 1 is 255. 2 to the power of 32 minus 1 is this, 429, etc. So this kind of largest possible 32-bit number is what we're writing here. And that kind of makes sense, right? Two's complement wise. So we're going to have to store these numbers as unsigned numbers, and then we're just going to have to leave it up to the operations to interpret them. That's the... I feel like I've dwelled on this for far too long. But anyway, so we're going to have to find a way to, when we see these numbers, interpret them as not just an unsigned number, but as specifically a 32-bit unsigned number. Like, it makes me realize that actually here I've said interpret integer and just provided a string, but actually you need to know how many bits wide. I'm just going to make that explicit. Because I can see that this is going to be a problem later on. And I could just write code inside here that's specialized to 32 bits, but I know that I'm just making work for myself if I don't do this at this point. So let's say this is always going to be, because this is i32.const, we're always going to be interpreting it as a 32-bit value, and likewise up here, because this said i32.const, we're interpreting it as a 32-bit integer. Because if this was being interpreted as a 64-bit integer, this denotes a different unsigned value. Like, then it's denoting this. You can see, in fact, the same test is repeated. But you can see that if it's a 64-bit integer, then -1 is equivalent to a much larger number, because it's a 64-bit binary number where every bit is set to 1, right? So we've got to be width aware in this interpret integer function. I think the reason why I'm banging on about this is I'm trying to delay the point where I have to decide how to implement this, because I can think of at least 3 ways of doing it. I've already showed you one of them, this one, which is fine as far as it goes. I dislike it. What do you mean, Adam? Arrays of ints. I'm not sure what you mean, sorry, but please feel free to clarify. I'm just going to quickly say the other 2 ways that I know how to do this. One of them is, I've already showed them. One of them is to do a subtraction. So if I want to, bits equals 32. If I do 2 to the power of bits and then subtract whatever it is, if I'm trying to represent -1, if I subtract 1 from 2 to the power of how many bits, that gives me the, if I've got n bits, 2 to the n minus 1 gives me the n bit representation of -1 in this case. The other way of doing it is the other way that I showed when I was doing this sort of 42 example, which is that you can, if you use bitwise not, that's not very useful, is it? How am I going to show this? Maybe if I use sprintf to show yes. Okay, that's a bit cryptic, but I want to format this as an 8-bit binary number. So, I mean, I know that's literally what I typed in, but now I'm going to operate on this, and I want to show you what the resulting 8-bit binary number is. Oh, I suppose it doesn't, I don't need to specify. Yeah, that's okay. All right. If I do bitwise not, it's going to flip all of the bits of this number. Now, I actually haven't really thought about how this works under the hood, because, like I said, because Ruby numbers are sort of arbitrary precision, what does it mean to flip all of the bits? Like, every number in Ruby has got infinitely many 0 bits high. Most significant bits are all 0, and then a finite number of ones in the least significant bit. So if I flip them, I'm going to get an infinite number of ones followed by a finite number of zeros. Right, okay, yeah, I vaguely remember this. So sprintf, sorry, once again, I'm just pulling something out of thin air. Let's go to, I guess this is in kernel. Yeah, it must be. I'm going to try and hack that URL. What does this do? Returns the string resulting from applying format string to any additional arguments. So this is basically just formatting. The percent means that I'm going to have some number or something special, and the special thing I'm going to show is a binary number with, why have I left the 0 in there? I suppose that's not really doing anything. Yeah, sorry. Previously I was using that to say that it should be 0 padded, but so sprintf or sprintf is doing a thing here where it's putting ... and I think this is exactly what I was talking about. An infinite number of 1 bits followed by 0, 1, 0, 1, 0, 1. And then, so like I said, you can take the ones complement of a number and then you can add 1 to it. So if I take the ones complement of this and add 1 to it, then I get this 1010110, which is minus 42. So I suppose if I'd done this is really quite confusing. So Ruby is interpreting this bitwise not. It is interpreting it as a signed number, but it's not operating in like an 8-bit or a 32-bit world. It's sort of operating in this sort of arbitrary size number world. And I mean, more to the point, you can see that, like, what I want is, sorry, I'm sort of in this sort of 42 analogy so that I can use nice narrow numbers. Like, what I want, the answer I want is 214, right? That's what in this case, that's what I'm trying to get, is like, if in a WebAssembly program I saw the number minus 42, I would want to represent that as 214, and then that can be interpreted as either the positive number 214 or the signed number negative 42, depending on the instruction that I pass it to. And this does not immediately get me that. If I do bitwise not on a number in Ruby and try and do like 2's complement, like it just gets me back to where I started. So that's not super useful, although I guess the way, I don't know what happened there. I guess the way out of that is to mask it off. So if I do bitwise and with, I'll write it out longhand. So if I strip out this infinite number of most significant bits by just doing bitwise and with an 8-bit number, then I will get 214. So there's 3 different ways of doing this conversion. Hi Klaus, welcome. So which do I prefer? The thing I dislike about using, although like using pack is very, basically Ruby's doing the work for me there, which is great. And I'm very happy for that to happen as much as possible. The thing that I think the thing that I was instinctively unhappy with about this was that I want this function to be parameterized on the number of bits. And here, this method is not parameterized on the number of bits, at least not directly. You need to know these cryptic pack and unpack. Look, I'm looking at a completely different set of cryptic things for printf there. You need to know these L's and Q's and S's and things like that. So this is inherently less general a solution because you're only picking from a sort of a limited menu of things that Ruby already knows how to do. And furthermore, I'd have to have a hash or something that stores, well, what's the pack format and the unpack format for 32-bit numbers. And that's, totally doable. It just feels a little bit gross. So I'm not very keen on that. This is okay because this is kind of explicitly. So, I mean, what is this in general? Because that number there is 2 to the 8 minus 1. Sorry, I'll parenthesize that a bit more clearly. So this gives us 2 to the 8 gives us the number that's 1 too large to be represented as an 8-bit number. So if we subtract 1 from that, we get the maximum 8-bit number, which is all the ones. And in fact, maybe it's better to think of this as being 1 shifted left 8 places. So it's like, yeah, that's just taking a binary 1 and then shifting it left 8, multiplying it by 2 8 times, so shifting it 8 positions to the left. I.e., this number, which is 256, which is the same as 2 to the power of 8, but I think this is the sort of shifting notation makes more sense to me because it helps me to visualize. I'm always worried about like fence post or like off by 1 errors when I'm trying to think about, it's 2 to the power of 8. That's not an 8-bit number, it's a 9-bit number, whereas with this, it's like my weak brain finds it easier to visualize this, I think. Yeah, I think the picture in my head of 1 shunted left 8 positions makes it easier for me to think about the number. Anyway, the point is, here we do have an explicit, bits. How many bits are you using? So here, if I said 1, not 1 plus 1 and 1 32 places to the left minus 1, that gives me the number I'm looking for, right? Flip all of the bits to get the 1's complement, increment it to get the 2's complement, and then mask out the low 32 bits to give us what we need. I haven't talked about the third way, which is just subtraction. Did I talk about that? Oh yeah, I did. So yeah, that's the other way of doing this, right? Is just like that actually gives you the same answer. For that 42, I could do 1 shifted left 8 times minus 42 gives me 214. So now, having talked all this out, I think maybe this is the nicest one because it's definitely the easiest. It's got like the least. It's got the fewest moving parts, and also it's just directly parameterized on the number of bits, so I don't have to some kind of weird mapping to be able to get the value that we want. I'm as I'm talking, I'm realizing I'm spending way too much time on something that is really not important, but I just wanted to get this straight in my head. And like I said, part of the reason I'm doing this is I want to try and be clear about the code I'm writing. So actually, I think maybe I need to remind myself of those principles more often, because I think both this and this suffer from being quite cryptic, whereas this, I mean, it's all cryptic if you don't know what signed numbers are, but actually I think this operation really gets to the heart of what we're talking about. Like, the whole reason why 214 is the 2's complement representation of 42 is because it's precisely 42 less than that sort of rollover value, and it's that sort of odometer, all of the values rolling over is like what gives us subtraction like behavior, gives us negative number like behavior. So I think maybe this is the clearest distillation of it. So anyway, having spent way too long making that decision, I'm now getting that enact it. So what do I want to do? So the thing is, what I need to get the sort of the magnitude of the number, which is this. I'm still going to need to use toString, but like, I don't really want to. What I'm saying is I don't really want to get a signed number back from 2i. I really just want to get the size of the number back. And then I want to separately, if it's a signed number, then, do the 2's complement thing, else it's just magnitude, right? In fact, I can just write this down. What's the 2's complement thing? It's 1 shifted left by bits times, and then subtract the magnitude. So that is easy to write. Where I'm thinking that this signed is something that tells me whether there was a minus sign in front of the number or not. So signed equals string start with minus, and then I suppose what I want to do is strip that out. There is a method that can do stripping out, string translate. So return a copy of str with the characters in from str replaced by the corresponding characters. So you can use this to do, this does, character-wise replacement. So here, E is being replaced by I and L is being replaced by P. But you can also use it for stripping if you just give it like this. So here, if you give it the empty string, it will just remove stuff. I'm not sure if there's a nicer way of doing it than this, but this is habitually what I do. So if I've got minus 42, I can just say translate the minus character into the empty string and I get 42 back. So I think I'm going to do that. I know there's a version of this with a bang that will mutate the string, but that makes me feel a bit ill. So I'm remembering whether the string was signed, and then I'm stripping the minus sign off the front of it if it was there. This will just be a no-op if there's no minus sign, so that's fine. And then we do this thing of getting the magnitude, and then we either we do the 2's complement thing here or we don't. So it feels like a very long time since I've executed this. Oh, wow. Okay. That's good. So that's actually got me as far as here. It looks like all of these, or rather all of these assertions have passed. So all of my shenanigans with negative numbers has clearly worked. So that's good. I'm glad about that. But now I've hit an instruction, this I32. There's no there's no match for that in this evaluate pattern match. So I think, yeah, I'm well overdue for a commit. I think I'm just going to stick all this in one commit, because even though I really made several changes there, that none of them make very much sense in isolation. You don't need to know whether it's signed or not unless you're doing this stuff. You don't need to know how many bits it is unless you're doing this stuff. So I think I'm just gonna, it's more than I would normally commit all in one go, but I'm just gonna say, oh, I really don't like that. I'm sorry. I'm gonna first just add this argument. So the commit I've made there is just adding that bits argument to interpret integer, which I should have done. I should have just made that commit back then so that I didn't have to do that diff surgery just then. But as you can see, the diff surgery doesn't really bother me. Add mandatory or required bits argument to interpret integer. We need to know how wide the number is so that we can correctly interpret negative, so that we can correctly convert negative numbers into uninterpreted integers. And given that, oh, I don't like that. Given that idea came from this bit of the spec, I'm just going to leave a link to that. Right. Now, yeah, I'm fine with that. So now let's say, I suppose just support negative numbers in interpret integer. I'm having real trouble typing the word interpret today, I notice. So just very briefly, in fact, can I... It makes me realize that I've made a bit of an assumption here, which is substantiated by the executable specification. So I think it's fine, but I've just made an assumption that WebAssembly uses 2's complement. And I mean, that the reason why I made that assumption is because I can see from the test that it does. But this must have, that they must have to specify this. It's not written anywhere here unless I assign numbers. The reason I'm fishing for this is because I'd quite like to be able to link to something that justifies this. So let's look at runtime, execution, numerics. It's pretty depressing how long it takes for that MathJax to load in. I'm not a fan of that at all. Oh, here we go. This is what I should have read in order to implement the thing I've just implemented. Numbers have an underlying binary representation as a sequence of bits. Okay, so that means that fundamentally we're being asked to think about numbers in WebAssembly as just a sequence of bits. Now, I think it's okay for us to use Ruby integers as a sort of a bag of bits, right? Like treating a number as a bit field is pretty natural. So I think I'm going to resist the temptation to interpret this as like, oh, it should be a, you know, I should actually represent numbers as an array of Booleans. I think that's probably a step too far. But here we go. Integers are represented as base 2 unsigned numbers. And this is, I mentioned last time that this is quite a mathematical spec, and we're already getting into that here, where it's sort of saying integer bits of some width n. Yeah, right, Adam. This is definitely what you meant. You were close in a way. I think, yeah, the sort of array of bits is obviously where they've gone. And yeah, I mean, I guess we could think of this as, so this is saying d here, I think, is a meta variable that's ranging over, the meta variable d is to range over single bits, yeah, which is what I was about to say. So this is saying that the bits of an integer are, if it's an 8-bit integer, you've got d7, d6, d5, d4, all the way down to d0, and then the actual number being represented, which is I, is 2 to the power of 7 times d7 plus 2 to the power of 6 times d6, all the way down to 2 to the power of 0, which is 1 times d0. So that's just explaining how to represent an integer as a sequence of bits, which is very helpful. But this gives me hope that there's going to be, it says Boolean operators are lifted by applying them pointwise. That's good to know. That means that in this spec, if we see like a Boolean and between two numbers, that actually means bitwise logical and on the bits. Don't care about floats yet. Here we go. This is exactly what I wanted. Sign interpretation. Integer operators defined on, remember, in were those uninterpreted integer values. I think. In defines uninterpreted integers. Yeah, okay. So, I'm going to try and remember this. U means unsigned, S means signed, and I means uninterpreted, which is not begin with U. I guess I means integer. So I'll sort of think about, there's U and S are the two specific flavors of integer, and I just means, who knows if it's signed or unsigned, but we represent that as an unsigned value, i.e. as that sequence of bits that we just talked about. Operators that use the sign interpretation convert the value using the following definition, which takes the 2's complement when the value lies in the upper half of the value range, i.e. the most significant bit is 1. Okay, right. So this is... Yeah, I was going to say this is the inverse of the function that we've been doing. This function is bijective and hence invertible. So this is talking about the opposite. This is saying if you've got one of these uninterpreted integers and you want to know what its signed value is, this is the way that you convert it. And this is actually the inverse of the function that we just implemented. So this is the thing that if I gave it... crap. What was 256 minus 42? 214. So here, if I say I've got 214, what number does it represent? It's like, as an 8-bit signed number, it's like, well, you have to subtract 2 to the power of 8 from that. So 214 minus 2 to the power of 8 is indeed minus 42. So, and bijective here just means it's a one-to-one mapping. So that's why it's invertible, because if you take this function in one direction, it can only the result of the function corresponds exactly to that there's one input maps to exactly one output, and so there has to be a function that goes the other way. That's the worst explanation of a bijection I've ever given, but my brain's not in the mood for talking about bijections and stuff. Anyway, the point is that this actually says the words 2's complement. So this is what I want, sign interpretation. This is what I want for my commit message. And I probably should have come and checked this, but the reason I didn't was because these executable specifications were making me use 2's complement anyway. So it was sort of obvious. But let's spell it out here. Wasm uses 2's complement to represent signed numbers as a sequence of bits. So that's what this reference says. And I suppose notice that, I should have been more excited about this. They've chosen the same way of, they haven't said we're going to do a bitwise. we're not going to like subtract 1 and then do a bitwise and not. They're just doing this subtraction business. So I feel like this vindicates me. Retroactively, this vindicates my choice of method of conversion. Like, that's one more reason to do it this way, is because this actually matches what the spec is saying. And it may be that I actually need to define, I can see actually at some point I am going to need to define this function as a method, as a helper method, because I'm going to need to be able to do this. And when I define that function, have it be exactly what the spec says, and then for the inverse of this function to be, actually, maybe I need to extract this as a helper, but I'll think about that later. Should I be extracting the inverse of signed as a helper function? But I don't need to do that yet. Anyway, I'm glad I did it this way. WASM used 2's complement to represent signed numbers as a sequence of bits. What's actually in this diff? We can implement this by subtracting, by spotting negative numbers in the S expression and subtracting their magnitude from 2 to the power of n, where n is the width of the number in bits. Fine. Okay. So I feel like we're probably going to make it through this. Because now all I've got to do is implement addition, and I know how to do that. So let's do that. And yeah, I feel a little bit bad that I haven't been writing any of those little unit tests, but I don't know. I'm enjoying just chewing through this acceptance test, and it's, it's failing fast on the next thing that's broken, and none of these are... The main reason why I drop down to unit tests when I'm working like this is because I feel like I need to get more of a grip on the problem. Like, I might need to have a simplified case, for example, which was certainly the deal when I was implementing the parser, right? Like, I needed to write those unit tests because I needed to have a radically simpler string that I was trying to parse in order to sort of drive out that functionality in the parser. But here, all of the failure messages are giving me something that's so simple to deal with that it feels like it would just be busy work to write a unit test, so I'm just not going to bother. So to make this work, we need another case in here in i32.add. Is that what it's called? Yes. i32.add. LHS, RHS. No, I'm going to call them left and right. Now, again, I'm a little bit skeptical about this because, well, as of right now, I don't know anything about the semantics of i32.add. Like, for example, can it take an arbitrary number of arguments? I don't know. In this file, it only takes 2. I don't know if that's universally true. And also, like I said, I'm sort of nervous that it should probably be taking these... It should be able to take arguments off the stack, and I don't have a stack yet. I'm just using the Ruby evaluation stack to recursively, well, I haven't written the code yet, but what I'm going to do is evaluate the left-hand side, evaluate the right-hand side, and then add them together. So the only stack being used here is the call stack in MRI to remember that I'm, it'll evaluate this, and then that'll get sort of that value will get temporarily saved while we go off and evaluate this, and then the resulting value will be added to the one we remembered from before, and we will get the result. But I'm not going to worry about that yet because I don't need to worry about it. I reckon this is going to work. Okay, so we got a lot of these. We got all the way to, how many is this? 1, 2, 3, 4, 5, 6, 7. Expected 0. Got 4, 2, 9, 4, 9, 6, 7, 2, 9, 6. 1, 2, 3, 4, 5, 6, 7. So it's this one. Number 8. Neg 0. I32 const 0. What does neg 0 do? Crap. Well, if you subtract 0, if you subtract 0 from 2 to the power of 32, you don't get a 32-bit number. You get a 33-bit number. But of course, that's why this is here, is to check that I've implemented that properly. And I have not. So let's implement it properly then. Two ways of doing this. One of them is to have 0 as a special case. I'd rather not do that because special cases feel a bit gross. The other way of doing it is to just mask the resulting value off to be the right width, which I know is something that I said I was trying to avoid doing earlier, but now it sort of feels like maybe I do need to do that. I wonder if, so before I disappear down a rabbit hole of doing this myself, I wonder if this function is invertible. I wonder if the inverse function is already defined here somewhere. Because that's what I'm trying to implement. So like if it was in the spec, that would be, I would just do whatever that says. It doesn't really matter, does it? It doesn't matter how I do this. I'm just scanning through this to see if it's like, oh, here's how we characterize the inverse of this signed function, because if they'd already characterized it, it just would have been nice to just copy and paste it figuratively. But they don't seem to have, or at least if they have, I haven't immediately found it. No, there's nothing in here about it. And I doubt there's going to be anything in here about it. No. Okay. All right. Well, I mean, it's okay. I can implement it. Just thinking about this for a second. Like, why is this? I'm just trying to think about whether there's something obvious that I'm missing that makes this elegant, but it doesn't really matter, does it? one thought that's intruding is that I can imagine a situation where the Ruby operations that we do here, so like this addition, for example, like this could overflow and give us a number that's too big to fit in 32 bits. I mean, I know we don't have that problem yet. But the relevance of me saying that is because I'm sort of thinking, in that case, probably the right thing to do is to mask it off so that so that we're only taking the bottom 32 bits, right? If I don't know, it depends on what the semantics of this of WebAssembly says, but you know, that feels like a sensible default, is just to mask the result so that if there was an overflow, well, we've lost those bits that are outside the 32 least significant ones are gone, and we just keep the bottom 32. And that's sort of the reason I'm saying that is because that's sort of what's happening here. Like, we're sort of getting an overflow because we're subtracting 0 from a number that's too large to fit in 32 bits. So that's one case where masking off the bottom 32 bits would just automatically give us the right answer. And it just occurs to me that that's likely to be the case for addition as well. So what I'm going to do for now, I think, is write a little helper, value bits. And so this will be value bitwise ANDed with 1 shifted left bits minus 1. So that's going to give us, if you pass in, just to remind you of what the heck I'm talking about here. Bits equals 8. That gives us 255, which in binary is 8 ones. So that gives us an 8-bit number, and in this case we want a 32-bit number with all of the bits turned on. So that's just going to give us that's going to discard anything above that number of bits, right? So where do I want to call this? The temptation is to do it in here because this is where the problem is, but then it sort of makes me realize that actually, more generally, there's no guarantee, even though you pass in a bits argument here, there's no guarantee that the result of this function is small enough to fit into that many bits. So actually, this interpret integer function isn't making any guarantees about the width of the value it returns. Maybe it should. Yeah, I feel like it's going to save us pain later if it does. So here, let's say value equals. So we're sort of going to mask this regardless of whether it's gone through this, because actually the problem exists here as well. You know, this string could be 500 characters long and bits could be 32. So I think it's sort of most correct for us to say mask that value to be the right number of bits, and I think that's going to fix that problem. Yeah, okay. So now all of that is... So I think that's, even though, well, I mean, I don't know actually, maybe there were tests that were checking when that number is too large, but I can't see any. But, you know, that sort of, this is defensively fixing a more general problem than the one I was trying to fix, but I think it's sort of applicable in more places than just this, so I might as well get the benefit of it here. So what am I saying here? Oh, yeah. Okay, so let's do this first, because this is really the motivation for it. Implement the i32.add instruction. And then here we're going to have to say mask the result of, what's it called? Interpret integer? Yeah. To be the right bit width. We need this immediately to correctly support -0, but more generally, it's probably going to, it's probably important that the result of interpret integer fits within the requested bit width, regardless of whether the number was negative, which it won't unless we always mask it to the right width. So that justifies that. How are we doing for time? I think I've got time to finish this. I think it would be nice, and I can see that the end is really very close because when we run this, you can see that the failure now is saying that I don't know what I64 what specifically is this complaining about? Oh, it is specifically the fact that there's an I64 const here is what's preventing it from working. But we have the technology to do that. If I here put I64.const, then that will, in the first instance, fix that error because now there is a pattern that matches it, although this 32 has now become extremely suspect. So I'm imagining that we're going to see a problem with the semantics here. Oh, what we're going to see is a problem with I64 const in evaluate, I guess. Yeah, sure enough. So we also need to teach evaluate about I64.const. I64.add. Oh dear. Well, that's not good, is it? Who watches The Watchmen? So all of those tests are passing, but unfortunately they shouldn't be, because all of these values are being interpreted as 32-bit values, and because I put that masking in, these are all just being masked off as 32-bit numbers, and that's all fine. So that's a bit embarrassing, isn't it? Is that necessarily the case? I can't immediately in my head tell whether it's possible to write an assertion with this limited palette of things that we can do that would catch that problem. It's not obvious that it's impossible because we have got the ability to like calculate with these values. So maybe you can brew up something that would catch my wrong here. But nonetheless, I have to fix this because I know it's wrong. I'm just hesitating because I sort of think, oh, is this a point where I could write a unit test that actually demonstrates that this isn't right? No, the problem is I can't immediately formulate that test, and maybe it can't be done. It probably can, it's just that I can't think of it. But let's instead justify it by saying, like, there's a magic number here, 32, that shouldn't exist. So I'm just thinking a little bit about how to handle this, because you can see that in two places here we've got, and like in two places here we've got like i32 dot something or i64 dot something. So this is what this is doing, is making me feel tempted to refactor it, but it's not entirely necessary yet. Let's just get it working. I mean, I know it's already working, but let's convince ourselves that it's doing the right thing. So let's capture this. What am I going to call this? Instruction. So that's going to put i32.const or i64.const in a local variable. Then I think I can use slice. I'm trying to think, how do I get the 32 or the 64 out? I think if you say i64.const, then you can use string slice, which is also just square brackets on a string. So this is showing me the documentation for square brackets. But you can put a regular expression in here to get a particular substring. So what I want is the substring that is, well, I guess I can just get the substring that is numeric. If I get the substring that is one or more numbers and then convert that to an integer, then that gives me, that's maybe slightly clumsy, but whatever, bits equals instruction.slice one or more digits to I, and then I'm no longer hard coding the bits in there. Now, I expect now this is going to give me the failures that I was craving. Yes, because now, I mean, this is exactly the error I should have been seeing before. It's just that unfortunately the bug was present both in the code that was calculating the expected value and the one that was calculating the actual value. But this is what should have happened, is that I expected to get this huge 64-bit number, but instead I got this 32-bit number. And that's because I need to do something like this down here. I'm going to duplicate this, and then I'll refactor it away, but let's just get it passing. So these need to have the instruction stored away. Oh, actually, this one doesn't, does it? I don't know why I did that. It's because I wasn't thinking. Yeah, this one, although this needs the pattern match, we actually don't care. Oh, that's weird, isn't it? See, like I was saying, I think we ultimately do care, because if this addition overflows, we need to mask the result to the right size, the right width of integer. And at the moment, we don't even know what the right width of integer is, but we don't actually need to know that right now. So I can get away with just jamming it in there. Oh, of course, I have to actually use that bits. Okay, so I mean, I suppose, all right, I'm going to retroactively craft a convincing narrative here. I suppose that these tests, while the software is saying they were passing, like, we should have, by looking at this output, we can tell that they're not really passing, because this is, in order for this, in the same way as when we were running the parser, it was because we didn't know what the required output was. We were really just eyeballing the output. I think there's something similar going on here, where it's like, well, okay, this is the output of those assertions. If any of them fail, then obviously it's not working. But if they pass, they're producing this output, which we then have to like sense check against like what's in this executable specification. And you can see that these numbers are massive and they're not showing up anywhere in these assertions. So it's obviously not right. Whereas here, these massive numbers are showing up. So that seems, this is much more convincing to me. I think this is what we should be seeing. I just noticed that there are these tests at the end about separators. So this is testing that it's okay to put underscores in a number, it looks like Ruby. I mean, I know that Ruby supports that syntactically as a Ruby number, but it looks like 2i also supports that. Yeah, okay, so we didn't have to do any other work to make that happen. Fine. So what is this? Support i64 const and i64 add. Yeah. Yeah, okay. All right, so we're nearly done, which is good because it's been nearly 3 hours. Like I said, I just wanted to sort of tidy up. Specifically, the thing that I want to tidy up here is this. I don't like... I can see that this is quickly going to get unwieldy because I'm sure there are more operations on integers than const and add. And what I don't want is to have to do this... Well, both this have an alternate in the pattern and then also capture it so that I can slice out the number of bits. Like, that feels like it's going to be necessary all over the place. So what do I want to do about it? What I want to do about it is I want to write a single pattern here that will match any i32 dot whatever or i64 dot whatever instruction, so that this here can just be a nested case that's just matching on const, comma value, add, comma value, or add, comma left, comma right. And I want bits to be worked out up here. What am I going to call this? Operation. I want operation to be worked out up here. And then this code, which is actually width agnostic, as long as we know what, as long as we've got the bits, we can just write this code on basically the bit after the dot. So I mean, I think this can just be a regular expression, right? Like here, this can be, oh, okay. I'm just thinking this here actually needs to be something like this. I mean, this isn't ideal. Sorry, I'm jumping all over the place here. What I'm thinking is this can be a regular expression that's like and let's be explicit about it, 32 or 64 dot whatever. Oh, I wonder if I can use, there's this thing in regexp, last match, that lets you interrogate. I mean, this is really gross because this is sort of global, or I guess like thread local, I hope, information where you can ask questions about you can get the match data for the most recent. So would this work? I feel a bit gross doing this, but here, if I made a capture group here and called it bits, so this is, I'm not going to bother looking in the documentation, but this is a bit of syntax that you can do in a regular expression where you can say like the thing between the parentheses is something I want to capture, and then the thing within the angle brackets is a name I want to give it. So I want to name this bit bits, and I want to name this bit. I mean, really, I can name these whatever I want, but I'm going to name them the same as the local variables that I want to put them in. So does this work? I feel like I've written a lot of code here and I've got no idea whether it works. So now I don't need to do this. If I can do that, then this is just match equals regex last match. Try not to be sick in your mouth that I've done that. But now I should be able to say match. How do you pull out named matches? Oh, it's match data I want to look at, isn't it? It's probably just square brackets or something. Yeah. I think it is. Which isn't my favorite, but you know, that's what the documentation says to do. I would rather have like an English word, but I don't think it has like fetch. So this would be match bits. Oh, look, actually, I've just realized I can use destructuring assignment because it has got values at. So why don't I do that? Why don't I say, instead of these 2 lines of code, why don't I say bits operation equals match values at bits operation. I mean, if this code works, that'll be a miracle. Oh, it didn't work. Oh, because bits needs to be an integer. Oh, that's a shame. Okay. Yeah, I don't really like that. I guess I don't really need this local variable. Oh, it's okay. I think it makes it clearer. I think it makes that clearer. Okay, cool. I mean, this was kind of my final refactor and cleanup before stopping, I think. I mean, I could put that. I could, yeah. I should sort of do the same thing up here, shouldn't I? Just for, again, to sort of be consistent. Because otherwise I've got 2 different mechanisms for making this work. I'm just thinking about what I want to happen here. Yeah, I mean, I don't actually care about the operation here, do I? Oh, actually, I do care. It needs to be const. So let's just say that. I know this is unnecessary, but I'm just a bit uncomfortable about having 2 different ways of doing the same thing. So I'm gonna just make this the same, just for the sake of it. And this actually does make it more explicit that that we support 32 and 64-bit here. So I think that wins on the explicitness front. Match equals regex last match. Bits equals match bits 2i. And the reason I'm doing that immediately afterwards is just because that makes me slightly less panicky about this regex last match, because like, if you're not doing this immediately after the regular expression match has succeeded, like, you know, if I was doing it after this code, then it's like it could go badly wrong if I decide I want to do a regular expression match inside here. So I want this to nuzzle right up against the point where the regular expression match is happening. I really dislike this about Ruby. I wish there was a better way of grabbing the match data, but I don't know a better way than that. So if I comment that out, does this still work? Yeah. Okay. I'm conscious that now I've got these slightly grim regular expressions in my code, but I think I could have, thinking about it now, I could have called split on this string, but I suppose the point is I wanted to match this sort of syntactically I number dot something else. So anyway, I'm not gonna lose any sleep over that. That's a commit. Well, seems like this is the standard MO for me, is that I decide it's a commit, I get out everything, and then when I look at the diff, I'm like, oh no, that's too much. What I want to do is just commit this bit, because this was really this is the motivator. So this is like recognize all i32 star and i64 star instructions and extract the bit width. So yeah, I think that's clear. And then now I can say use the same technique, same regexp technique. Well, let's say recognize i32.const and i64.const inside assertions with a regular expression, and then I can say this is the same as how we do it in evaluate, which hopefully makes it clearer that it's the same. It's a solution to the same problem. And the final thing I wanted to think about is, are these optional? Can I take these square brackets out? Because that is a bit nicer. Yeah. Do I want to do that? Or does that make it? Yeah, in this case, it's sort of a reduction in clarity, isn't it? Okay, I'm not going to do that. There was just a devil on my shoulder saying like, oh, you could take some characters out. But I think thinking back to my claim that I wanted to prioritize clarity over cleverness, this feels like a case where, it definitely feels like a case where I want to I want to make it obvious that thing is an array. Sorry, I'm just cycling through all my League Against Tedium overlays there. So I think I'm going to leave it at that. That's good, isn't it? Well, maybe it's not good, but it's something that at least all of these assert return assertions are passing now. I've learned, crucially, I've learned something about the way that integers are represented in WebAssembly, and I've thought a little bit about how I'm going to deal with, I expect this is going to continue, that I need to deal with the impedance mismatch between the low level integers or the low level values that are present in a WebAssembly program and the sort of much higher level numbers that are available to me as a Ruby programmer. So I've needed to sort of, I've needed to implement 2's complement on a specific width of number, even though the underlying hardware kind of already knows how to do that. Or if I was writing this in C, is that true? It's just in a string. Anyway, I don't know. I feel like I'm having to I feel like I'm undoing some of Ruby's hard work here, where it's like under the hood, we've only got 32-bit or 64-bit integers anyway, but Ruby's sort of hiding them under these arbitrary precision integers, and now I'm sort of trying to recreate the experience of having fixed width integers in order to make these tests pass. But I think that, like I say, I've sort of learned something about how that works. I think I'm just heeding my final refactor and cleanup before stopping. I can't think of anything immediately that I want to do here. I'm a bit unhappy about how long this line is, but would it really get any clearer if I broke it up? Like, if I do this, is that better or worse? I mean, it's still syntactically valid. How do I feel about that? Yeah, maybe that's less bad. Yeah, okay. I think that's going to be my final. That's going to be my final bit of tinkering. Wrap long pattern. It's not very beautiful, but all right. So let's git push. That's all up on GitHub now. Maybe next time my little bit of faff will be getting the test running with GitHub Actions. But for now, I'm happy that this is now available on the internet for anyone who wants to look at it for some reason. And oh yeah, the final thing I was going to do, just as I suppose as a teaser for next time, was now that those int literals is working, I think maybe I want to move on to one of these. I'm not sure what the difference between I32 and I64 is versus int exprs. So I32, so this looks like this is going to be testing the implementation. We've already got an implementation of add, so this is going to be testing submul. My blood has run cold because I can immediately see that we're going to have to implement support for function parameters here. But otherwise it looks like this is going to be sitting on top of what we've already done. So what does int exprs do? Test interesting integer expressions. These tests contain code patterns which tempt common value changing optimizations. Well, don't worry about that acceptance test. I am not going to implement any value changing optimizations anytime soon. This looks a little bit more involved. Although it's still the same kind of thing. It's just I32 operations on values. Anyway, the point is I was just going to see if I can run this. Like, let's leave it, Murray style, leave it with a failing test. Okay, so this is where we're going to pick up next time. Basically, it doesn't know how to define a function that's got parameters, because in my pattern I said it says func and then export with a name and then result, and then it's got the body of the function, but here it's got params. So we're going to have to implement params, and then we're going to have to implement this is going to be slightly boring, sorry. We're going to have to implement, in addition to addition, we're going to have to implement subtract and multiply and divide and all this other stuff. We're going to have to look at the spec and work out what some of these operations actually are. I can anticipate what some of these are. I can see there's population count, rotate left, rotate right, shift left, presumably, shift right. Oh, signed and unsigned. Okay, so we're going to have some interesting stuff is going to happen. So, yeah, that's what we'll do next time. Well, let's call it a night then. Thanks for watching this. I feel like this wasn't necessarily super interesting. I know it was even more laborious than last time. It's taken me 3 hours to implement really a very simple thing. But I hope that you enjoyed it. Thanks very much for watching. I'll see you next time. Goodbye.